Hi, my name's Nick Clements and I'm delighted and honoured to be asked to present a keynote for the FuturePrint Virtual Summit. I'm actually the business planner at Landa Digital Printing, but some of you may also know me as Dr. Nano because I'm a passionate advocate for our technology and for the science behind nanography. Now you may think that's a bit strange. Why is a business planner so interested in the technology and the science behind it? For a very simple reason. We make a lot of claims for our technology about the speed, about the print quality, the subject range, the sustainability of the printing process. And we can make those claims because we're not an evolution of another printing technology. We're not a development of an existing printing process. We're something entirely new. We're a new printing process. And because we're new, we can do things that nobody else can do. So that's one of the things that I want to talk to you about today at this session. What is it about our technology that makes us so special? But I also want to show you how we are implementing that technology in our printing presses today. What it looks like when we take this technology and we scale it up and we put it in a modern printing press. So I'm going to take you a bit later for a short tour of one of our printing presses to show you how it works. So those are the two aims for today. Now I want to start with the technology and what makes us so special. There are two things that make our technology so special. The first is the ink we use, and the second is the process by which we apply it to the paper. This is nano ink. What makes it nano ink is that every single pigment particle in here is less than 100 nanometers in diameter. What's a nanometer? A nanometer is 1/1000th of a meter. Now let me give you some idea of what that means in terms of scale and proportion. I've got this coin here in my hand. Now imagine if in the other hand I had the planet Earth. That ratio of the planet Earth to this coin is the same ratio, the same proportion as a meter to a nanometer. Planet Earth, this coin, meter, nanometer. So when we say that all of the pigment particles in our ink are less than 100 nanometers in size, it means they're really small. They're on the scale of hundreds of atoms in size, yeah? Okay. Big deal. We've got really small pigment particles. Why does that matter? What's so important about the size of the pigment particles? It's important because the size of the pigment particles directly affects the absorption of the light. The smaller an object becomes, the greater the surface area to volume ratio. Let me explain what that means with this cube, okay? So this cube, imagine it was a pigment particle. This pigment particle has a certain volume and a certain surface area, yeah? Certain volume and a certain surface area. Now, if I do this, I've still got the same volume of pigment particle, I've just got a lot more surface area. And if I was to do that, I've got even more surface area, but still the same volume of pigment particle. And if I was really dexterous, I could do that again, but I'm not, so I won't. But you get the point. The more you break down the size of the pigment particle, the more surface area you're creating without increasing the amount of volume. What that means is Landa pigment particles, for the same amount of volume as conventional pigment particles, have a lot more surface area. And that's critical because it's through the surface area that the light is absorbed. So the more surface area you have, the more light you're absorbing. The more light you're absorbing, the more bright, the more intense, the more dense your colors are. You have a much wider color gamut, a much wider range. So the first thing that's special about our pigment particles, because they're small, is they absorb more light and so they can create more intense, more vibrant colors. Now you actually don't want all of the light to be absorbed. You only want the light to be absorbed at the wavelength that you're interested in. The rest of the white light you want to pass right through. When that white light is reflected back from the pigment particles as scatter, it creates a kind of an interference in between you, the viewer, and the colors that you want to see. Now, got another complicated chart for you here. I promise you this is the only one. But what this shows you here is the amount of scatter that occurs depending and the size of the pigment particle size. And what you can see is that the maximum scatter occurs when pigment particles are around 300 nanometers in size. Now, there's no coincidence that that's the typical particle size for titanium dioxide, which is used for white ink, because you want all the white light to be scattered back, you want it all to be reflected back. But what you can see is that there's a lot of scatter around this area, and this is exactly where offset inks are in terms of their size. Now, Lander ink is less than 100 nanometers in diameter, and below 100 nanometers you have zero scatter. That means none of that white light is being reflected back. None of that light white is interfering and obstructing the colors that you want to see. Imagine you were in a cinema and you're watching some amazing blockbuster film. You know, there are big explosions on the screen, lots of bright lights, lots of fantastic colors. Then somebody walks in and they switch on the lights. Suddenly everything that you see on that screen, it's a bit faded. You don't see such bright colors. And that's exactly what's happening, typically when you have white light scattered back. But with Lander, because the white light, there is no scatter, because our pigment particles are so small, you never have that effect. You only see those pure, brilliant, bright colors. And that's why we're able to achieve the amazing colors that we do have. And I'm not sure if you can see this, but I just want to show you. Here we have two examples. This was printed on offset in conventional printing technology, and this was printed on a Lander press. And you can see the difference in the colors. They're more bright, they're more vibrant, they're more intense. Why? Because you've got those tiny pigment particles which are absorbing all of the light, and none of the white light is being scattered back. You can see it also here on this B1 poster, where you can see the first strip on the top is conventional printing, then nanography, conventional printing, then nanography. Hopefully what you can see there is how nanography brings the colors out. It makes it pop, it makes it stand out so much more. So, to summarize, because of our nano ink, we're able to achieve much richer, deeper, more vibrant colors than conventional printing technologies. And we also need to use a lot less pigment particles in order to do that. So that's the first part of what I wanted to talk about, what makes Lander such a special, unique printing process and allows us to achieve so many different things. That's the ink. The second part of it is how that ink is applied to the paper, to the substrate. Now, we don't apply the ink directly to paper as you would do with inkjet technology. Now, inkjet technology is a wonderful technology, but it has a number of failings, and all of those failings derive from the simple fact that you put wet ink on paper. When you put wet ink onto paper, some of that ink is going to soak below the surface of the paper. Now there, the pigment particles are ineffective, so you actually have to put down a lot more ink so you have enough of the pigment particles above the surface to absorb the light waves that you want to absorb. Secondly, if you have a very porous surface like an uncoated stock, then you often see that the ink will spread on the paper and you'll get a breakdown and distortion of the dot shape. Conversely, if you have a very porous paper, like a coated or a glossy stock, then the ink won't adhere to the surface of the paper and you'll get a sort of a rivering effect as it pools on the surface of the paper. Now, another problem with putting wet ink onto paper is that paper doesn't like getting wet. What happens when you make paper wet? It kind of distorts, it gets all damaged, yeah? So you're limited in the amount of wet ink that you can put on the paper because you don't want to cause a lot of damage to it. And by the way, the more wet ink you put onto it, the more water you're putting onto the paper, the more drying you have to do. You have to dry more intensely, and particularly if you want to maintain faster speeds, you have to dry it quite intensely. And that, again, limits the amount of water that you can put down because you can't, if paper just doesn't like getting hot, if you blast it with a lot of heat, you're going to damage the paper again. So you either have to slow down the process or you have to put less water down, which means less ink, which means less surface coverage. Lander overcomes all of these limitations for one simple reason. We never let wet ink get into contact with paper. We jet ink onto a blanket where we form the image. We dry the image on the blanket, and only when it's completely dry do we then transfer it over to the substrate. So the ink is always dry before it makes contact with the substrate. The ink stays on the surface of the paper. It's like almost like a laminate applied to the surface of the paper. None of the ink soaks into the paper. None of the ink spreads along the fibers, and none of the ink rivers on the surface of the paper. Also, because we don't put wet ink on the paper, there's no water to soak into the paper, and we don't need to dry the paper. We never heat or dry the paper. The drying is all done on the blanket away from the paper, so we never have to worry about damaging the paper. And for all of those reasons, we're able to create perfect print qualities every time. Now, that's a lot of theory. What I want to do now is go to the presses and show you how we've implemented that, and hopefully it'll become a little more easy when you can see how it works on the press itself. So come with me please, and we're going to go and see a Lander S10 press in action. And here it is, the beating heart of the Lander nanographic printing process, our print engine. And isn't it a thing of beauty? Now what I want to do is just give you a quick overview of the printing engine itself. So if you look here, you can see our blanket. The blanket is going through here, it comes up under the print bars here where it collects the image. That image is then transferred by the blanket along here all the way to the dryers. The dryers remove the water from the image. The image then is the blanket continues to take the image around here to where we have the impression drum, where the image is transferred to the substrate, and then the blanket continues back on its journey through the blanking cooling unit and ready to come up and collect another image. And that's it. Really a very simple, easy process. Now what I'd like to do is go into each one of those subsystems in a little more detail. So let's start with the print bars. And here we are at the back of the press, so we can take a closer look at the print bars. I'm just going to open one of those up for us here. Now what you can see is that we have 7 print bars, and each one of those print bars has 24 print heads on it. Each print head has 2048 nozzles, and each nozzle jets out 80,000 drops per second. So you do the maths. 7 print bars times 24 print heads times 2048 nozzles times 80,000 drops per second. That's roughly 27,525,120,000 drops per second. That is how many drops this press is capable of jetting out every single second. To put that in perspective, that's roughly the same number of drops as there are in a thunderstorm over New York City. So what you can see here then is that although we may use the same print heads as other press manufacturers, we use the Fuji Diomatic Samba print heads, where we bring something unique to it is in the software, the control systems and the algorithms that allow us to place those 27.5 billion drops every second onto a blanket that's moving at 100 meters per minute. And we are placing them to within 50 microns of accuracy on that blanket. That's the incredible capability that we bring here. So as I said, these are the print bars, these are the print heads, and they're jetting that ink onto the blanket. So let's now go and have a look at the blanket itself. And this is it, the Lander blanket. The blanket itself is 11 meters long and 1 meter wide, and it's a belt that continuously loops through the print engine. And the blanket has one job and one job only, and that is to ensure that we have perfect print quality on every sheet that comes out of the press. How does it do that? Well, the blanket itself is actually a critical part of Lander's IP. It's made of a composite material. The outer layer of that is a silicone rubber that's a hydrophobic material. That means it repels the water in the nano ink, so that as the blanket goes under the print bars and the ink is ejected onto it, the dots, the drops of ink all sit perfectly on the blanket exactly where they were placed by the print head. So that each drop of ink sits exactly where it's placed. The blanket itself is heated to around 72 degrees. So as the dots of ink hit the blanket, they immediately start to dry. We also have pinning units in between each one of the print bars that just give a little bit of a blast of heat to fix those dots into place. The blanket then takes that image all the way through to the dryers here, where the remaining water is then dried out of the image and the print quality is completely fixed and formed. That's the role that the blanket plays within the nanographic printing process. We form the image on the blanket, we fix the print quality on the blanket, and only once that print quality has been completely fixed, then does the blanket take it through the impression drum where it's transferred over to the substrate, where there's no degradation of the image quality itself. The blanket then continues its journey here through the blanket cooling unit. The blanket cooling unit is kind of like a wash for the blanket. It does 3 basic functions. It cools the blanket because it's critical for us to ensure that we maintain an even thermal gradient across the blanket. So the blanket coolant unit cools it down and makes sure that there's an even thermal gradient on the blanket. It also cleans the blanket because there's a lot of imperfections in the air, dust particle, paper particle, those sorts of things, because we're working in a normal operating environment. so it kind of removes all of those imperfections from the blanket so they don't interfere with the print quality. And then finally, it conditions the blanket ready for the next pass through. And the blanket goes up and takes the next image. And that's it, very simple indeed. Now what we can't show you here is the actual transfer process itself. So what we've done is we've created a sort of demo back at the studio which shows you how that transfer process happens. And that's where we're going to take you to now. Okay, and now for my favorite bit. We have spared no expense and invested in the most sophisticated technologies to be able to replicate for you exactly what happens inside a Lander nanographic printing press. We're going to show you live how the image is transferred from the blanket to the substrate. This is amazing, so please watch carefully. Now, what we have here are some sections of the blanket. Now, these are being pre-printed with an image, mainly because I can't produce 80,000 dots per second. You probably can't even see it, but there is an image on there, but it's incredibly thin. It's only half a micron thick. Why? Because of those nano pigment particles. Yeah, they're so powerful that you only need a very, very thin layer of ink in order to be able to create the image. And also, there's no scatter, so all you're seeing is the light passing through to the black blanket underneath. But trust me, there's a beautiful, vibrant image on there. So I'm going to take this amazing image and I'm going to place the blanket, onto this hot plate, which, trust me, is hot. I just burnt myself on it. It's heated to around 72 degrees, the same temperature as the blanket on the press. So we're heating the blanket up to the same temperature as on the press, and now we're going to simulate passing that blanket underneath the hot air dryers. And for that, we have this very sophisticated hot air drying technology. Some of you may be familiar with it. Okay, that's it, that's all it needs. Remember, it's a very, very thin, half a micron thick layer of ink, so you don't need much hot air to dry it out. So now, I'm just going to place the piece of paper on top of the image, and then take our second piece of highly sophisticated equipment. This is the impression drum, and just apply light pressure between the paper and the image on the blanket. That's all that's required. And now, there we go. Look at that. All those beautiful nano ink colors, all there on the paper. Stunning, beautiful image. And it's completely dry. There's nothing that you can do to smudge or smear that image, yeah? Why? Because the image is dried on the blanket. It's completely dry on the blanket, and only then is it transferred over to the paper. It's like, think of it as like a hot melt adhesive, yeah? Where once the hot image comes into contact with the cooler paper, it just bonds to the surface of the paper, and that's it. It's completely bonded to the surface paper. There's nothing that you can do to smear or remove that image. Now, like with all good demos, I'm going to show you that again, except this time I'm going to try and show it to you in a slightly different way. So let me take another segment of the blanket, exactly the same, same image printed on it. Again, you can't see it, but trust me, it's there. Let me get rid of the old blanket. Place that on the hot plate. Let's not miss that out. Okay, there we go. So that image is now completely dry. So look really closely as I place the paper very, very gently just onto the image. Can you see that? It's completely dry. The image only needs a light contact and it immediately bonds with the cooler paper, and it's completely dry. Let me show you again. Just take the paper and place it gently on there, and look at that. Okay, completely dry. Amazing. Now, I want to show you what's left on the blanket after we've removed the image. So I'm just going to take this piece of paper, place that over the top, and as before, a bit of light pressure, nothing too much. there, and just remove what's left of that image. You can see it matches up pretty closely with what we took off there. So now, let me take another piece of paper and I'll show you what is left on the blanket after we've done the transfer. So again, just apply a bit of pressure. Doesn't have to be a lot of pressure, just light pressure across there. And there. That is what is left on the image after the transfer process has occurred. Nothing, absolutely nothing. The entire image is transferred over. Isn't that amazing? Okay, so that's kind of an overview of the nanographic printing process, yeah? The image is formed on the blanket. The blanket itself is specifically designed to hold each one of those dots in exactly the position that we want it to be and to maintain the shape and structure of each one of those dots. Then they're dried in place. That means that the print quality is completely formed and fixed on the blanket. Only when that print quality has been completely fixed do we then transfer it over to the paper. So there's never any interaction between the wet ink and the paper. The print quality is formed on the blanket, and then the image is laminated to the surface of the paper, just like a hot melt adhesive. It's laminated to the surface of that paper. And what that means is we can print on any substrate without pre-treatment or without any priming, and you get the same amazing print quality on every substrate that you print on. So if you look over here, you can see we printed the same image, but each time onto different substrates. You've got everything from silk matte to uncoated to glossy paper, and it's exactly the same quality of image. This is tissue paper, and you're getting the same quality of image as any other substrate. Why? Because the image quality is formed on the blanket, and you take that dry image and you laminate it onto the surface of the paper, so it sticks just on the surface of the paper where you get those amazing colors all on the surface of the paper. You can see that there's, even with the tissue paper, you can see there's no stripe through there. And we get the same high quality of print image regardless of the substrate you're printing on. And again, we can print on any substrate without primer, without pre-treatment, because of the nanographic printing process. Okay, so that was the nanographic printing process. Now, there's a lot more to a press than just the print engine, just the process by which the ink is transferred to the paper. What we want to do now is show you the rest of that process, everything else that goes to making a lander press today. And let's start at the feeder. So let's go. Okay, so let's start our tour of the rest of the press here with the paper transport system. Okay, what you can see here is a standard sheet transport system provided by our partner Komori. It's the same sheet transport system that you'll see installed on thousands of Komori presses around the world. Some of you may even have it in your factories at home. It's been custom engineered to fit with the Lander printing engine, but apart from that, it's the same sheet transport system as Komori use on their offset presses. So it's solid, it's robust, it's reliable, it's everything that you expect from a sheet transport system. And in there, in the feeder, you can see exactly the same as you would have in your offset presses. B1 sheets, anything from 60 to 800 microns, and you can print on any off-the-shelf stocks. So there's no need for a priming unit, there's no need for pre-treated papers. It's exactly the same off-the-shelf stocks that you would use on any of your other offset presses. So you don't need to worry about having multiple stock keeping units, you don't need to worry about multiple paper suppliers, you don't need to worry about having the right paper in stock at the right time. You just take the same stock that you're using on your offset presses and put it into the Lander feeder. And that sound you can hear there, that's 6,500 sheets per hour going through the press. So let's follow those sheets as they go through the press. They're going through the bridge and from the bridge into the print engine. So we're running out of time, so I'm going to have to speed up a little bit here. What you can see is the sheets coming through here from the bridge. They're going around the impression drum. That's basically the rolling print that I was showing you in the demo before. So the sheets are then going through here. What we've got here is the Active Quality Management System, the AQM. Now that's an automatic closed loop inspection system. What it does is it scans every sheet as they're going through the press and compares it to a digital original, digital master. It allows the AQM to ensure excellent registration and also to identify and correct for any print defects from missing nozzles or anything like that. The AQM can also act as a sort of a print qualification system as well, so it can verify that each sheet is meeting your customer's specifications. Once it's gone through the AQM, the sheet is then going along here. Now, if this was an S10P, a perfecting press, that's where we'd have the perfector, and that's where we'd have the second impression drum. But this is an S10, this is a single-sided, so the sheet's just continuing all the way through there to the coater over there. Now, you don't have to have a coater, but on this particular press, we have a coater in line. It's a conventional coater, Harrison Bruno. It's hybrid. You can either have UV or aqueous. It can be flood or selective coating. Again, just a conventional press, conventional coater, exactly the same as you would have on any of your B1 presses on your production floor. And really, that's the best way to think about this press. It's a standard conventional press from the feeder all the way through to the stacker, the coater, whatever. The only difference is the way by which the image is applied to the substrate. That's the nanographic printing engine. That's what's different. Everything else is the same as you would have on your other B1 presses. It's just a Lander nanographic printing engine that's transferring the image. So let's go now and see the end of that journey where those sheets come out. Okay, and there it is. Look at that. 6,500 B1 sheets per hour coming through the press, digitally printed, every sheet different. Isn't that a thing of beauty? And that's 6,500 sheets per hour. It's not the top speed, it's not the average speed, that's the only speed. You switch the press on, it's printed 6,500 sheets per hour. Now, I'm just going to ask our operator, Nir, who's been running the demo today, to take out a couple of those sheets to show you, because I'm not going anywhere near the press because I'm scared I'm going to break it. Thanks, Nir. And that's what I want you to see. Look at that. Stunning colors, intense, bright, vibrant, clear lines, sharp edges, fine text, really, really high quality, and every page is different. That's what you get with the Lander S10, 6,500 sheets per hour printed on any carton board off the shelf in amazing print quality and digitally printed where every page can be different. Thanks very much, Nir. Now, let's go back to the studio for a quick summary. Thank you. Okay, I think that's all we've got time for today. So I hope you guys have enjoyed that as much as I have, and hopefully it's given you a little bit more of appreciation of our technology, the science of nanography, what makes us different from any other printing technology, and because we're different we can do things that no other printing technology can do, and also what that means when you scale it up to an industrial scale printing press, a modern printing press, the capabilities, the abilities, the features that puts into your hands. Now, I know this has been a little bit sort of high level and theoretical, but my colleague is giving a session this afternoon where he's going to go through with you how the S10 printing presses are changing the packaging market today, the impact that they're having at our customers around the world on different segments and different verticals within the folding carton market, how it's affecting our customers' business, how it's changing their business, and the impact it's having on them. I would strongly encourage you to view that session, to see that session, to get a greater appreciation for how Lander can support your business. Thank you very much. I hope you enjoyed the session, and we look forward to partnering with you in the near future. Thank you.